Hi everybody. We're going to discuss the chemical equilibrium and the reversible reactions. In the reversible reaction in a closed system, there will be equilibrium. Of course, we have types of reactions. Some of them are called reversible reaction. They have these symbols of arrows. They have a forward and a backward arrows. So in the chemical equilibrium, we have two meanings for this definition. First, that the rate of forward reaction is equal to the rate of reverse reaction. For instance, we have here a reversible reaction. Nitrogen gas reacts with hydrogen gas to give ammonia. So here we have, if the rate of nitrogen and hydrogen will react to give ammonia, will be the same rate that ammonia returns back or dissociate to give hydrogen and nitrogen back. So if the rate of forward equal the rate of reaction of backward or reverse reaction, that means that there is an equilibrium in this reaction. Also, if the concentration of reactants and products are no longer changing, they are the same, they are constant. The nitrogen and hydrogen in a closed system will be the same concentration. Nitrogen and hydrogen and ammonia are the same concentration, never one of them will be more than the other. At that time, we can consider that the reaction is reversible at equilibrium. So, there is of course factors affecting equilibrium. Le Chatelier, it was a rule, and it gives conditions for applying this affecting positions of equilibrium. First factor affecting the equilibrium is changing temperature. So for changing temperature, we have two types of reactions. One of them is exothermic reaction, and the other is endothermic reaction. Of course, we know the difference. Exothermic reaction when heat is given out. So nitrogen, when reacts with hydrogen gas, it gives ammonia, and hydrogen is given out. We call this reaction exothermic. If the nitrogen gas react with oxygen gas and give nitric oxide, reaction is not given out, is taken in, and we call this type of reaction is endothermic. We're going to see what the effect of changing temperature on first the exothermic reaction. Of course, when we increase the temperature of exothermic reaction, what we are going to do? We know that the exothermic reaction here, that means that we have high heat. There is a lot of heat with the products, high heat. And with the reactants, it is low heat. So if we increase the temperature, according to Le Chatelier principle, the increasing temperature will move the reaction to the reverse or to oppose. So if we increase, it will go to the low temperature. So increasing temperature moves the reaction to which hand? We are talking about here the left hand side and the right hand side. So to the reactants, it is the left hand side. Hand side and hand side. And to the, if the products, we're going to say right hand side. So here the reaction, if we increase the temperature, the reaction will move to the left hand side. Why left hand side? Because here is the low temperature. It is an exothermic reaction, as I told you. And here is a high temperature. And increasing will lead to opposite. If we increase, will lead to the low. Okay? So let's see if we decrease temperature. Of course, if we decrease temperature, the reaction will move to the opposite side, where the temperature is high, at right hand side, correct. So the reaction will move will move to right hand side or moves to right hand side. For endothermic reaction, what will happen if we increase the temperature? Endothermic reaction means where is the high heat? The high heat here with the reactants, because it take in heat. So they take in heat, so this is the high temperature and this is the low one, low temperature. So if we increase the temperature, it will move to, yes, correct, to the right hand side. And if we decrease the temperature, what will happen? As I told you, here is the high because it take in heat. It is an endothermic reaction. And here is the low. So the temperature will be, if we decrease the temperature, the reaction will move to left hand side. So the temperature here we decrease, it will go to the high temperature to left hand side. Another factor affecting the position is concentration. So here the concentration, we have a closed vessel. As I told you, it's a vessel containing nitrogen and hydrogen and ammonia in a closed system. So if I add a nitrogen, I'm going to increase the concentration of nitrogen gas, or I may increase the concentration of hydrogen gas, or I may increase the concentration of ammonia. I will start. If I increase the concentration of the reactants, either nitrogen or hydrogen, what will happen? As I told you, Le Chatelier principle says that it will oppose the action. So if increasing the concentration, it will go to the low concentration. Where is the low concentration of nitrogen and ammonia? Is it at the left side or at the right side? Of course, there is no here hydrogen or nitrogen. So increasing the concentration of the reactants will lead to the right. There is no here concentration, so it will go to the low. So increasing concentration of nitrogen or hydrogen will let the reaction move to right hand side. What will happen if we decrease the concentration? It will move to the high concentration where nitrogen and hydrogen found. So it will react back, right, move, it will react or move to left hand side. If we increase the concentration of products, now we're going in the same system, closed system, we're going to increase ammonia. I'm going to increase ammonia gas. What will happen? So the ammonia gas at the product is concentration increase, so the reaction will go to the opposite. Increasing, it would go to the low. There is no ammonia in the reactants, so the reactants will move to the left hand side by increasing the product or ammonia. What will happen if we decrease ammonia? The reaction will go to the increase, which there is ammonia, so it will move to the right hand side. Another factor which also affects the equilibrium is changing pressure. Changing pressure depends on the equation and balancing the equation. We took before how to balance equation, nitrogen 2 in the product 2 multiple 1, so it's 2. Hydrogen 3 times 2, 6. Also ammonia hydrogen here 2 times 3, 6. So it is balanced. How we go for the pressure? We have to balance first the equation. Then we have to know the moles. Behind here, we don't write the 1 always. So that means that the nitrogen have 1 mole. And from the equation also, we have 3 moles of hydrogens in the reactants. In the products, we have only 2 moles. So 4 moles in the reactants, which is high pressure or high mole. When we say high moles, number of moles, that means the pressure is higher. And here we have low pressure, because number of moles here is less than the number of moles with the reactants. Now let's start when we increase the pressure. What will happen? The same, according to Le Chatelier principle, it will oppose the factor or the action. Increasing pressure will lead to move to the where the pressure is decreased. So where the pressure is low, it will means it will move to, correct, it will move to right hand side where the moles is less. يبقى the answer we're going to say because mole is less with the products, so the reaction will move right side. What will happen if we decrease the pressure? It will move to the higher pressure with the reactants, so it will move, the reaction will move to left hand side. Now using catalyst. Of course, catalyst doesn't affect the equilibrium, it only affects the rate of reaction. It increases the rate of reaction. But on the equilibrium, never. The same, because we mentioned before that the forward reaction equal the rate of backward reaction or reverse reaction. So the catalyst will not going to affect. Haber process, how to perform, or how Haber process is performed. They brought nitrogen gas and hydrogen gas to form ammonia, and we call this process a Haber process. From where do we get the source of nitrogen? From methane. And from where we get the source of hydrogen? From methane, and the source of nitrogen could be from air. So when they react with each other, they form ammonia. Conditions for Haber process, very important. Temperature 450 degrees Celsius. The pressure is 200 atmospheric pressure, and the catalyst is iron. Also, we have another process which is called contact process to perform sulfuric acid, where one of the steps is a reversible reaction, which deal with the sulfur dioxide reacts with oxygen to form sulfur trioxide gas. Sulfur trioxide gas reacts with sulfuric acid to form oleum, and the oleum will react with water to give 2 molecules of sulfuric acid, which this is the reversible reaction. Of course, we got sulfur dioxide from burning sulfur with oxygen, roasted sulfur with oxygen, we gain sulfur dioxide, or by sulfide ores with carbon to get sulfur dioxide also by reduction with carbon. Finally, sulfur dioxide, we have it, and we take the oxygen from air to form sulfur trioxide. The temperature, the condition for this process is very important. Same 450 degree Celsius. The pressure 200 kilopascal or 2 atmospheric pressure, and the catalyst here is vanadium 5 oxide. Let's go for the question. Is a compound, the question is about compounds of phosphorus. Gaseous phosphorus 5 chloride decomposes into gaseous phosphorus 3 chloride and gaseous chlorine. When the three gases are present in a closed container, the system reaches equilibrium. Complete the table using only the words increases, decreases, or no change. So let's start. Increasing temperature. Of course, the rate of reaction we took before, that the rate of reaction increases by temperature and decreases by pressure and increases also by catalyst. But what about equilibrium? Increasing the temperature, here the yield, which means the product, the word of yield means product of phosphorus trichloride and chlorine increases. Let's move to the pressure. What will happen to the pressure here? How we go for the pressure? Let's go for the pressure. The pressure here increases. How did I get the answer here? I will count here 1 mole, and here 1 mole, and here 1 mole. So how many moles in the reactants? 1, and 2 moles for the products. So if I decrease the pressure, it will move to the high moles, number of moles were the products. So it will go to the products with the yield will increases. And then, of course, add the catalyst, it will increase the rate of reaction. And then the table shows that when the temperature increases, the equilibrium yields of phosphorus trichloride gas and chlorine gas increase. State what conclusion can be made from this reaction. How we know that this reaction is an endothermic or an exothermic reaction. So from this information, I can get that increasing the temperature increase or let the reaction moves to the right hand side. So when I increase the temperature, it means it will go to the low temperature. So when it is low temperature, that means it is not an exothermic, it is an endothermic because it taken heat, up heat. So this reaction is endothermic reaction. Okay, ammonia, another question. Ammonia is made in an industrial process starting with nitrogen. The equation for the reaction is shown. Name the industrial process used to make ammonia. Of course, we know it is Haber. State the raw material from which nitrogen is obtained, from air. State the symbol. What we mean by these two arrows? Reversible. State the temperature and pressure of this industrial process. Of course, Haber, it's 450 degrees Celsius, and the pressure is 200 atmospheric pressure. Name the catalyst used in this industry process. It is iron. Now, the forward reaction is exothermic reaction. So, exothermic reaction means here is high heat. So, what will happen? State the effect, if any, on the position of equilibrium when the following change are made. Explain your answers. Temperature is reduced. So if we decrease or reduce the temperature, what will happen? And if the pressure is reduced? Let's start with the temperature. Of course, the temperature, when we decrease the temperature, it will move to the high direction where the temperature. So it will move to the right hand side, because it is an exothermic. And the pressure, how we go for the pressure? Here is 3 plus 1, it is 4 moles. And here it is only 2 moles. So if we reduce the temperature, it will move to the high moles where the left hand side. So in decreasing the temperature, equilibrium moves to the right hand side where the reaction is high, as the reaction is exothermic, and this for 2 marks. Pressure is reduced, equilibrium will move to the left hand side because more moles on the left hand side. Okay, thank you.